today. Okay. Yeah, accidentally. Okay, I'm not going to do it here, but it's going to be accidental. The official day to open is actually on the last day. Okay, so let's yeah. Which one? McDonald's, right? Okay, loving it. Okay, so let's continue from here. This one, Okay, so I believe you have no problems with these, right? Okay, this is all okay now, right? Okay, this is all okay, huh? You can use, you can create using a list. You can create a copy using a slice, right? And that's what we did. Okay, we can create copy using a list comprehension, which I didn't show you, but I think we've gone through list comprehension before, right? Yes or no? Yes, huh? Should be quite fun, right? No. Have lah, we have gone through lah. I mean,
we did a list of examples.
yes, we did a list of examples. Okay, okay, just in case you can't remember list comprehension, I'm going to show you now. Okay, again, very quick one, okay. Just list comprehensions. I'm sure we did. It's just that it's not a lot of examples. The list comprehensions, okay. Yes. I guess so. List of lists. Yeah, it's not, I know it's not a lot. Okay, I can show you now. Okay. Let's say, for example, for list comprehensions, I think we didn't go through a lot of examples. I'll just give you a few examples. Things that you can do with list comprehensions. Let's say, for example, I want to find I have a set of scores, and these set of scores come in randomly. Okay, I'm just randomly typing a score. Okay, so you don't have to follow mine. Okay, so we have this set of scores, right? And we want to use list comprehensions, okay, to find greater than 50. Okay, we can do that. So we can get all the passing scores. Okay, to get all scores that are positive, that are expanded list of lecture directory. What do you mean by expanded list of the lecture directory? You mean this one?
Yes.
I thought we had that already. Okay, yeah, okay, can. Okay, so to get all scores for that are even, okay, to get all scores that are even, to get all scores that are from okay, let's say we just want to get scores that are only distinction but not HT. So distinction, what's your distinction? What's the score for your distinction in your module? Because I teach different schools, I have different. I don't want a distinction. I just want distinction. 75 to 85. Different schools different because I've taught schools like, for example, their passing mark is 40 to 50, 75 to 85. Okay, 75 to 85. That means we are getting all distinctions only, right? All distinctions only. Okay, so using list comprehensions, we can actually do that. Distinctions are from 85. Higher distinctions are from 85 onwards. 85 onwards, right? To less than 85. Higher distinctions are from 85. I'm just getting all distinctions, not the higher distinctions. Okay. Okay, so this is very easy. This one is just passing scores, right? We will loop for X. Okay, normally I like to use the actual thing, like for example, for score in scores. Okay, if you do that, that means you're copying everything. Basically, you're copying everything. So, but if I want to get only 50 and above, okay, and you can actually print that. Right? Okay, so this is what we call least comprehensions. Okay, score for score in scores. So you're looping through each of these and calling them score. Right? Only if that item is greater or equals to 50, you will collect the item and put inside the list. So when you print out the list, it's like that. Okay, I can even do a bit more complicated stuff. Okay, I will show you in a while. Okay, like asking how many people actually fail using these comprehensions. Okay, later on we will do that. Okay, so second one, we just do some list for warm up. Actually, I like list comprehension because it's only one line. Yeah, I like things very nice. Okay, so let's say even scores. Okay, even scores also pretty simple. Score for score in scores, if score divided by 2 gives you a remainder of 0. Okay, so these are all the warm-up. This is all warm-up only. Okay, this is all warm-up. Right, so you can see all the scores that are even, all the scores that are not even, they are thrown away. So far, okay? All good? Jackie, okay? Denise? Jeffrey? Okay, Fiona, okay, great. Ho Chin, Lee Ho Chin or Ho Chin Lee? Lee Ho Chin, Ho Chin Lee. Okay, I thought it's Ho Chin. Okay, sorry. Okay. Just kidding. You know who Ho Chin is, right? Okay. I'm so honored to have Ho Chin attending my class. Okay, let's continue. Okay, so next we move down to the third one. Okay, so this one I'm going to add in slightly one more criteria to get all scores that are from this sorted. Okay, in ascending order. Okay, sorted in ascending order. Actually, it's pretty easy one. Sounds difficult, but actually very easy. Okay, so we can say that distinction scores equals to score for score in scores. Okay, again, it's the same thing. If score is greater than 75 and score smaller than 85. Okay, so then you can see there's one thing that it actually asks you to do. So this is the one that you want to simplify the chain comparison. I actually know what to do, but just that I want to show you that this thing can happen. Okay, and this is good. When you simplify, it looks very easy. It becomes like this. Okay, so it becomes like math like that. This is like math, right? Okay, in other languages, you don't have this. You do MATLAB, you do Java, you do whichever, you don't have these type of chain simplifications. Okay, so we can print the distinction scores, but then we'll realize that it is not sorted. There's only one. Gosh. Then this is no good. You sure? 75 to 85. There's only one. Maybe time for me to add some more. Yeah, there's only one. Okay. Let me adjust down 86 to 84. Then adjust up this 73 to 76. Okay. So, okay, I adjust this to 76. So we have 76, 75, 84. Okay, 76, 75, 84, right? But now we want it to be sorted. Okay, we forgot about sorted, right? Okay, we need it to be sorted. Okay, so very simple, just like that only. Sorted. Done. Okay, just wrap the entire list with a sorted function and it's already done. Very, very simple.
So if we do the same thing on the top, we also sort.
Yeah. Yeah. Whether you want to sort or not. Okay, so all of you okay, right? Okay, right. So now let's do one more, just one more only. I know it's a very fast one, okay? Just to get you used to least comprehension, okay? Okay, let's say we want to get the number of students who fail. Okay, we want to get the number of students who fail. And there are 3 students. We know there are actually 3 students, okay? So normally, you will do something like this. Okay, this one don't need to copy. I show you the original way first. Then after that, I'll show you the least comprehension way. Right? The original way is you use this, right? Number failed equals to 0 for score in scores. If score smaller than 50, number failed plus equals to 1. Print number failed is number failed, right? So this is what you do, and you can see there are actually 3 of them. Okay, Okay, so how to do the least comprehension way? Okay, so let's see. Okay, so let's see how to do. This is the non-least comprehension way. So we do the least comprehension way. So this one is to get the number of students failures 50 least comprehension way. So we first do number failed. No. Okay, this one eventually will be a number. So let's try that first. Okay, this is normally we'll do something like this. Score for score in scores if score is smaller than 50. Okay, we print this number field is actually a list. That's not exactly what we want, right? Okay, that's not exactly what we want. Okay, so this, okay, sorry, just to differentiate, this is non-least comprehension. Otherwise, we will confuse. Okay, so this is what we want. Okay, so this one will show us the list. Okay, so we managed to get the list of scores that are below 50. All right? We got, but we are not getting the scores. We just want to count them. We just want to count them. So there are 3 of them, right? So instead of using the score, this is what we're going to do. For every score that is below 50, just give me number 1. So you can see 3 number 1s. So 1 student, 2 students, 3 students. Sum them up. Done. Okay. Interesting, right? Right, so you can see that if you do the least comprehension, 1 line, 2 lines, non-least comprehension, 5 lines, 1, 2, 3, 4, 5. Okay, any questions so far? No. No questions. Okay, so if wait for the guys over here to complete first, then I will switch back to the slides. Okay, see how much we have to cover. Not working. Which part not working? The least comprehension. Yeah. Okay. Takes time sometimes.
I see, can you see, I see when you run the.
It's like that. Just 3.
Yeah.
Okay, so if you're all right for the other side, okay, let's move back to the slides. Okay, so we are done with the list. So the next thing we're going to look at will be errors and exceptions. So after we finish that, there will be a break before we continue with chapter 9, right? Okay, so for errors and exceptions, normally there are three kinds of programming errors. Okay, syntax errors are probably the easiest to correct because it is due to the compiler, due to the interpreter. Okay, they will tell you what's wrong. Okay, second type of errors will be the runtime errors. So runtime errors are also not too difficult to correct. Okay, you run it, when you run, there's no problem. Halfway through running, there's an error. Those are what we call runtime errors. Okay, logic errors, possibly the hardest to detect if you never test your data properly, because your program runs properly, your program doesn't crash, but then the output is wrong. Okay, so just now when we run, we saw when we do a 3.14 minus 3, it gives us 0.14, blah, 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 right? Those are actually floating errors. Those floating errors, we can't get rid of that because those floating errors are part of the CPU. The CPU is not capable of there are some they have two things. One is called the FPU. FPU is the floating point unit. So somehow when you compute, there will be errors like this. So you have to do some adjustments here and there, right? Okay, so this is an example of a syntax error. So you can see that the indentation is different. So if I count the indentation 1, 2, 3, 4, so this one is correct. Okay, but the second one is actually wrong because there's only 1, 2, 3, three spaces, right? So when you run it, it will tell you that there's a problem, invalid syntax. Okay, it'll tell you invalid syntax. It's because of the indentation problem. Okay, if you fix it, okay, if you fix it, it'll tell you indentation unindent does not match any outer indentation level. Right, so all you need to do is to indent it properly, okay, and then you run it, and these two lines belongs to the if. Okay, so Python is done this way. Okay, other languages are not done this way, but Python is done this way. Okay, the downside, of course, is the indentation must be respected, but the upside of Python is that it's easy to code. Okay, you try. Have you ever coded, let's say, Java before? No, right? So you try Java, you will know what I mean. Okay. Okay. Another type of errors will be the runtime errors. Runtime errors is that when you run it, it crashes. It tells you that there's a division error. There's when you try to print a variable that's not defined, it'll tell you the name unknown is not defined. Okay. And if you try to add a string to a number, it will tell you that it's not going to work. Okay, so these are what we call runtime errors actually. Okay, it happens when it's running, right? So let's take a look at this. So age equals to input. What's your age? And then you key in 18. You're expecting a number, but you key in a word. So you will say value error, invalid literal for integer because you are passing in words instead of numbers, right? Okay, so this type of runtime errors, sometimes these are your fault. Okay, sometimes this is bad data, but again, bad data should be handled, okay, where possible. Okay, and to handle them, we need to use what we call exceptions. Okay, we need to use what we call exceptions, right? So exceptions means that you want to check whether there's a potentially any error. If there's an error, and this error can be found here, it will be handled. Okay. If there's an error in this set of commands or code, and if the handling can be found here, you will handle the code. Okay. If it cannot be found, then the program will crash. Okay. If it cannot be found, then the program will crash. Okay. Okay. So let's take a look at this. You try to print 32 divided by 0, it will throw you a 0 division error. Then you tell you cannot divide by 0, then it prints the end. Right? So what actually happens here? Okay, so this part of the code here is actually try. Okay, it's called trying, right? Trying to check whether this works. And if this doesn't work and there's an error that happens, it will be caught under what we call the 0 division error. Okay, so when the 0 division error is actually exception is actually caught, it will run the code inside here. Okay, and then of course you will run after you will continue with the program. Okay, if you never capture the error, you try to run it, it will simply crash. It will not print the end. Okay, right? So that's called elegant error handling. Okay, elegant error handling. Right, so you could try a set of command that could possibly have multiple exceptions. Like for example, you are asked to key in 2 numbers to divide, right? But you key in non-numbers. So you need to handle that. And let's say you key in 2 numbers to divide, 2 actual numbers to divide. Okay, and the denominator is actually 0, then it must be handled for the 0 division. Okay, so there are a few things to handle, right? So you can handle a few things at one time. Okay, but don't put all your code over here. Only those that is possible for, let's say, that particular error to happen, then you put the code inside the try. Okay, don't put everything there. Because when you put everything there, you are actually making the program inefficient as well. Okay. Okay, so this is an example. This is an example of, I wouldn't write it this way, but never mind. I use the example first. Okay, beer is equals to 300. So gas, you ask you how many gas to input, how many gas to night. Okay, so the guy inputs, let's say 10. Okay, 10, no issue, because you can convert the 10, which is a string, to a number. Your beers, which is 300 divided by 10, that will give you 30. Okay, so there's no problem at all. Then you will give 30 beers, okay, to each guest. Okay. The second example is that you put in 0. Right, you put in 0, you will successfully convert this to 0. But the problem is that you have 300 divided by 0, and that will give you a 0 division error. Okay, and it'll show you that you cannot have 0 gas. Okay. The third possibility is that you enter gas as a non-number. You put in 10. So you put in 10. So it tries to convert this to an integer. It fails. So you call the value error. Okay, cause the value error. And then it shows that that does not look like a normal number of gas. Okay. So far, any questions? No? I will show you how to build this part by part. Okay, I'll not build this like this I'll not write the full code just like this. I'll show you how to build this try and except part by part. Okay. So no questions on the other side, huh? Okay, you can have a default accept clause, but it is not a very good way to handle your code. Say, for example, you try to read data here, right? And you try to append a value inside the, for every line, you try to append and then convert that to integer, okay? Convert that to integer, and it fails. Then it says accept, print error, execution aborted, right? The question here is that you do not know what type of exceptions you're actually handling. Okay, what is actually happening? Is it because the value, there's a problem with the value, therefore I'm not able to convert this to an integer, or is it something else? Okay, useful to have a default exception rule, but I will say avoid it. Don't be lazy. Try to use something more meaningful. Okay, try to use something more meaningful. So you can see this is actually better, because besides the error when you fail to convert a value to an integer, it's also possible that you could not actually open the file due to permissions error. Okay, so sometimes you go on system, no, it's not your system, right? You log on to the server doesn't give you the permission. So that could be an error. Okay, maybe the file is not even existing, so that could be an error as well. Okay, so with exceptions, with useful exceptions, that will tell you where's your error, and you can handle your error better. Okay, exception is also an object. I think this part not so important. Never mind. Let's build our exceptions first before we go to the last few parts, right? Okay, let's build our exceptions. Let's go back to our PyCharm. Okay, so list comprehension can throw away now. Close it, close it. So this is the last part, exception handling. Okay, so with exception handling, let me see, how should I build the application? Okay, let's just ask for two numbers. Okay, let's just ask for two numbers. Number 1 equals to integer input. Number 2 equals to integer input. Okay, so you're just asking for two numbers and trying to convert them to integers. Okay, very simple thing. Okay, so we say we're going to do what we see just now, right? So we have the quotient equals to number 1 divided by number 2, and we want to print the quotient, okay, itself. Get used to writing this. Okay, so this will do the trick. Okay, so at the moment, I have not put in any exceptions. Okay, I have not put in any exceptions. Okay, so the thing here is this. Okay, in Python, you don't have to do that. you just run it first. And let's say I key in A. Right? Immediately it fails. It tells you that invalid literal for integer with base 10 A. Right? So you key in an A, and that's going to be wrong. Okay? So that means we need to handle the value error. Okay, we need to handle the value error. So very simple. Then the next question is you have to ask yourself, are all of these, okay, let me write a bit of more of the code. So let's say, welcome to the dividing program. Okay, and then print and of dividing program. Okay, something like this. Okay. So these two parts, right? Okay, so then you ask yourself, right, which will give you an error. Okay, so these two will give me the error because if I key in A here or I key in B here, it will give me a value error, right? Then you have to ask yourself this line here, does it matter if I key in A and I key in A here and that was actually handled? Will I still be able to divide the numbers? The answer is no, right? Because you are getting alphabets, you can't divide. Okay, so all these three lines are actually important. Okay, they are grouped together. Then of course the line number 8 is also important because if I can't get a number here, I can't get a number here, I can't do division, and therefore this one doesn't make sense, right? So all these 4 lines actually, they are one whole group because if one doesn't perform, the rest cannot perform. Okay, so you just ask yourself, then does the welcome and the end, does it really matter to the error handling? The answer is no, right? One printing at the top, one printing at the bottom. If you do saving of files, it's nothing to do with this program. Loading of files, nothing to do with this program, right? So that means we only need to handle this piece of code over here. So we highlight all of them, press tab. Our first thing we want to handle will be value error, okay, as value error, okay. So you want to print, oh, not catch, accept, sorry, too much of Java, okay. Print number 1, both numbers must be, both inputs must be integers, right? Okay, both inputs must be integers. Okay, so that should handle that. So let's try that. So let's try, if I put in A, okay, so it doesn't give me a result, right? Okay, which is good. Okay, the program actually ends gracefully. It goes all the way to the end, right? It goes all the way to the end. Okay, if I run 10 and I run B, again, it tells you that both inputs must be integers. Okay, so that means I've managed to handle A and B, no problem at all. So if I run 2 numbers itself, it shouldn't give me any message, right? It should give me the quotient, right? So if I put in 10 and I put in 5, it gives me the result. Quotient of 10 over 5 equals to 2. And that gives me exactly what I want. Okay. So from here, we know that we managed to handle the non-numbers. Okay, we managed to handle the non-numbers. The thing here is, of course, we always know that for division, there's always a 0 problem, right? So if you don't know the problem, you can actually run it again and then key in 10, 0, then it gives you a 0 division error. Every time you do not know the value, the error to handle, just make it crash. Once it crashes, it will give you the error. Copy the error. Okay, copy the error, copy this error, and then do an accept. Right. So I do not use this, yes, but if I need to use, I would already have the value, right? So we try again. Denominator cannot be 0. So if we run it 10 and 0, oops, I press enter accidentally. It shows that both inputs must be integers. So I put 10 and 0. It shows that the denominator cannot be 0. Okay, exactly what we want. Of course, you need to test again. Don't after handle it already, you think everything is okay. So we need to test one more time to make sure that the normal input works. Okay, that's how you handle errors. Okay, simple, right? Okay, any questions from the online side? No. Denise, all no. No. Fiona also no. Okay, no. Okay, then let's quickly jump back to the slides and then skip through a few slides, okay? And then we will go for a break. Okay, so we have managed to handle errors, and I told you that you should be looking out for different errors. Do not be lazy. Do not do a accept like this, okay? Do not do this type of accept. Is very lazy, okay? You could use the error as an object, but this type of errors are normally for programmers. Okay, so that's why I didn't print out just now. Okay, you can also raise a specific exception. Like for example, you can check whether the divisor is 0. If the divisor is 0, can actually raise a value exception. Okay. Well, I don't think you will need to do that. Okay, I don't think you need to do that anyway. You just need to do the try accept. Okay. If you are later you feel motivated enough, then you try this. Okay. Okay. So why not start your program with try and handle any error in the accept clause? Okay, this is like what I said, because it's inefficient. If you have a program, because now you're writing simple programs, but if your program stretches a few thousand lines, you can't be putting the entire program in the try catch. Okay, you have to capture the right error, the right area, right? But it's like if I ask you to hunt for a thief who has stolen something in 10 buildings. He's located in these 10 buildings. You have to go and find out, which building. You take a long time. But if I narrow down, this thief is only in this building, level 2 and level 3. He can't be running anywhere. It's easier to catch him, right? Okay. So we should not try and catch the entire program, because you could have the same error happening throughout different parts of the program, and then you have problems figuring out which line is causing the same error. That's also a big problem, right? You could have, let's say, line 2, line 3 causing value error, line 300, 500 causing value error, and you just handle them in one huge try catch. Then you have to figure out which one is actually causing the error. Okay, so do not do that. Okay, do not do that. Okay, logic errors. Okay, the last one is logic errors. The hardest type of error to detect. So you need to test your code extensively. Okay, this one nothing much we can do except to come up with test cases, make sure that it's correct. If it's wrong, then you have to rectify it. Okay, and the rest I'll leave it for you to do your reading. Okay, these are just why error handling is important. Because if it does not, then you will explode. The rockets can explode and stuff like this. All right. So ensure that you try to check your syntax. If the syntax is wrong, usually Python will tell you. So it's the easiest to fix. Second one, runtime exception, is also not so difficult. Okay, it's probably harder than syntax errors, but then you'll be also okay to fix. The last one is logic errors, possibly the most difficult to fix, but with extensive testing, you should be okay, right? Okay, so with this, we will stop here. We will take your usual 20 minutes, okay? 20 minutes break. You can go for a break, come back. We will start around 8.